Hello chemistry students, this is lesson 7.3 where we take a look at mass, mole, and particle conversions. So we're going to add to what we did in lesson 7.2. Goals for the lesson: we would like you to recognize Avogadro's number as the number of items in a mole. Given the mass or number of moles of a substance, convert to particles of that substance. So again, now we can go from masses to moles to particles and back again. From some number of particles, determine the number of moles or mass of a substance. So this is same as lesson 7.2, but adding an additional layer to it. Let's get started. So before we start into it with moles, let's take something that's a lot more familiar to everyone, the concept of a dozen. So everybody knows that 12 eggs in a box can also go by a dozen. 12 eggs equals 1 dozen. That's the basic equivalence relationship.
Yeah.
So we can use that to convert back and forth between eggs and dozens or any other amount of eggs.
So then if we come up and ask someone how many, okay, again, technology, how many eggs are in 2 dozen, you can either sit there and count them, or we can do some stoichiometry math or
So let's demonstrate the stoichiometry math here. So we want to know how many eggs equals 2 dozen. So we're going to again multiply by a conversion factor that we make from that equivalence relationship. 12 eggs is the same as 1 dozen eggs. So since we want to end up with eggs, we're going to put the 1 dozen on the bottom and the 12 eggs on the top. So the conversion factor is just a fraction with a value of 1, but lets us convert from one unit to another.
So equal to 24.
24, and you knew that already, but that's the basic
idea behind what we're doing.
Behind what we're going to be doing in this.
Because then if we took another dozen and brought it down, then you'd say, how many eggs in 3 dozen, same math, just slightly
And we
different.
could say how many eggs in
1,000 dozen.
1,000.29 dozen, and we could still do the math with exactly the same way. So that's what we're working towards. That's what we're going to be demonstrating in the next couple of slides with the concept of the mole now.
So then we're going to talk about the actual mole, and we need to point out that this is something you need to know, that 1 mole is 6.02 times 10 to the 23rd. If you remember, we had a Mole Day celebration that happened to be in October on the 23rd, and technically the day begins at 6:02 and ends at 6:02, but that part's not as important. But October 23rd is why it's 10:23, which is why we chose October 23rd. Anyway.
And that number is given the name Avogadro's number in honor of the chemist that first proposed the idea. He didn't actually discover how many things were in a mole. He just proposed the concept by which chemists later were able to figure out that this many things, this many atoms, this many molecules is a mole.
Yes. So the next thing is we have to start converting using Avogadro's number. So how many particles are in 0.25 moles? So again, we set this up the same way we've set them all up.
How many particles equals 0.25 moles?
And then you set up your...
I can do the fence post
There you
thing here,
go.
make Mr. Hunter students happy.
So,
Which is the same thing that I teach in my class. I just don't draw the little graphic, but it's
so on the
same
bottom we
idea.
have to use mole. So we know
Okay.
that for every 1 mole, there are 6.02. There you go, times 10 to the 23rd.
And in this case, we just use the unit particles.
Yep, because that's what they want us to do. So we do this math. We see times 6.02 times 10 23rd. Turns out to be 1.5 times 10 to the 23rd. I already did the significant figures for us, so we don't need to, do the sig figs on the fly now.
Okay, so if we have 1/4 of a mole, that's how many particles you have. Let's go on to try another example. We'll do it in the reverse now.
Mm-hmm.
All right, how many moles do we have if we have 300 billion iron atoms? That's a lot of atoms, Mr. Hunter. It's probably going to be a lot of moles. Or not.
So. Yeah.
Okay, so what do we have to do first? We have to take this 300 billion and change it into something that our calculator can work with. So that's going to be 3.00 times 10 to the 11th atoms. Okay, it was 300 times 10 to the 9th, and then I brought another 2 out.
Yep.
All right. So we want to change that into a number of moles.
So now 6.02 times 10 to the 23rd atoms would be on the bottom.
And just like we can have a dozen of anything, it doesn't have to be eggs. We can use different units on the number of things in a mole. The first one we use particles. Now we're using atoms. It's whatever the problem asks. But it's the number of things. That number of things can also be described as a mole of things.
Most commonly used are atoms, molecules, molecular formulas, electrons, ions.
Formula units.
Yeah, anything that's kind of tiny, we'd usually use Avogadro's number. And this comes out using 3 significant figures to be 4.98 times 10 to the negative 16. Just so happens Avogadro's number is much larger than 300 billion.
So yeah, the exponent of 23 will do that. So even though 300 billion seems like a lot, you don't even have 100th of a mole. It's a teeny, teeny, tiny fraction of a mole.
Yes. All right, next practice. All right, so once again, we're going to refer you to that mole diagram. You'll recognize this from as soon as you open your pink packet, you will see your mole diagram. Granted, if we use this video next year, it may no longer be pink. So the opening of your packet, you'll see the mole diagram. And of course, the most important part as well are the conversions on the bottom here.
There's all of our equivalence relationships.
Yes, I'm going to slide this back over to the part we need.
Because right now we're only working on the left side of the diagram. So this is a concept map of how to navigate around. So if we're given a mass, we can change it to moles. And this tells us how to get there. If we're given a number of moles, we can change it to particles, to gas volume, which we haven't done yet, or back to mass. Or we can do a two-stepper, which is like this one. Let's look at this problem on the left. How many molecules of sucrose, and I give you the molecular formula there, C12H22O11. That's the formula for table sugar, sucrose. How many molecules would be in 3.45 grams of sugar cube?
All right, so the first step is we need to take sucrose, which we have given you the molecular formula for, and can give out the molecular weight. So it would be 12 times the molecular mass of carbon, which is 12, plus 22 times the molecular weight of hydrogen, which is basically 1, plus 16 times 11, 16 being the molecular weight of oxygen, meaning there's 11 of them.
16 is the, yeah.
Yes. And it turns out to be 342.
342
with no decimal. I rounded
grams
per
mole. All right, now let's look at what we're asked in the question. The starting measurement we're given is a mass, 3.45 grams. We're asked to find molecules. So let's look at our diagram.
Here we are.
Here's where we're starting. This is where we want to get to. So you can see there's no direct flight on the islands here from mass to particles. So we're going to have to go through the moles and then to the particles. So that's our strategy. So we're going to go from mass to moles, then from moles to particles.
Yep.
So here we go. We're going to write down our given 3.45 grams. And our first conversion.
Oh, look at you. So we know that there are 342 grams in 1 mole. Since we started with grams, grams have to go on the bottom.
Because we want to lose that unit, 342 grams.
In 1 mole.
In 1 mole.
And instead of stopping and doing the math and having an answer, which you can do, it's more than fine, you can continue on. Now we are here in our conversion, and we still need to get here. So the next step is to go from moles to particles. So now we know there is 1 mole is equal to 6.02 times 10 to the 23rd molecules.
Okay, so I'm going to put the mole on the bottom now because I want to lose that unit. And I'm going to put Avogadro's number, 6.02 times 10 to the 23rd. And our unit is molecules.
Which, the crazy thing is, molecules is actually abbreviated by the word mole, M-O-L-E, where mole is abbreviated by M-O-L. So
okay, I wrote it out, but
it's probably smart at this point. Okay, so
I'm going to check my units.
Yep.
Grams divides out.
And moles.
Moles divides out.
And
we should be left, and that's the unit we want, so I think we have it set up correctly.
And then the answer is, when you hit the enter button, 6.07. This is me giving you the already significant figured
now, how'd you know there was 3 sig figs? Let's just talk about that.
3.45 has 3 sig figs. The molecular weight here is a given value, and 6.02 is a given value, so they do not count towards, nor does this one.
So all we need to do is maintain the same number of digits that there were in the
basically
original
everything
measurement.
here are given values, so they do not count towards sig figs, but 3.45 is a measurement, so we have to do sig figs. It's times 10 to the 21st.
I'll use your abbreviation MOLE, which is short for molecules.
Which is odd,
that is sort of ironic, isn't it?
Yes. Now, for those of you who are able to buy your own plane, you can take a direct flight from here to here, but I'm going to let you figure that out. I'm not going to explain it to you because we want you to follow the mole map for now.
Right, you can do it in one step, and it involves thinking about the bottom row there and the fact that everything on that line is equivalent to everything else.
So if you figure that out, let us know, and maybe we'll reward you. All right, have a good night.
All right, so we're going to end the lesson with 2 post-video questions. First one, how many molecules of water are in a liter? So it threw a little wrinkle at you here. Liters of volume measurement, not a mass measurement. But remember, for every milliliter of water, there's a mass of 1 gram. So you're going to have to convert your liters into a mass measurement first, and then you can answer the question. Second post-video question, what would be the number of moles in 10 billion, I believe that is, atoms of iron? So again, you're going to have to take that into scientific notation and figure out your number of moles. Don't forget about significant digits. Give those a try. We'll talk about them next time.